To find the double angle of sine, cosine, and tangent, the first thing we're going to have to do in this problem is draw it out. If my domain is in between 3 pi halves and 2 pi halves, then I know I'm in quadrant 4, because this is 3 pi halves and 2 pi. So let's go ahead and draw a triangle, a right triangle, with that being theta. Cosine is 5, the hypotenuse is 13, adjacent over hypotenuse. When I use the Pythagorean theorem, I get this length is 12, and directional-wise, it is negative 12. So our goal is to find these pieces now that I've drawn out my triangle. Here's the formulas for the three double angles. So let's figure out first, what is the sine, cosine, and tangent? The sine of, we're going to label this theta or u, we'll label it u. The sine of u is negative 12 over 13. The cosine is 5 over 13. And the tangent is opposite over adjacent. So now we're just going to use these formulas and plug in. This is 2 times negative 12 over 13 times 5 over 13. And when I simplify that out using my calculator, I get negative 120 over 169. Cosine. I could have used any three of the formulas, but I chose to use this one because I only have to substitute cosine once. I could have used any of the three. 2 cosine squared, which is 5/13. I can square it or I can write it twice, minus 1. When I put that into a calculator, I get negative 119 over 169. And the last one, 2 tangent, which is negative 12 over 15, divided by 1 minus negative 12 over 15 squared. When I simplify the numerator, I get negative 24/5. When I simplify the denominator, I get negative 119 over 25. Therefore, my final answer is going to be 120 over 119. There's all three double angle formulas.